All right, folks, we're going to solve quadratic functions by graphing them. The worst way to do solving quadratic functions because it's imprecise and it's ugly and whatever else. So, why are we doing this method? Why are we doing this lesson at all? I just like poo pooed the whole thing, right? I just said this is stupid. Why are we doing this? Well, here's the thing. We are doing this is even though this is after we learn other methods for solving quadratic equations. Actually, we already know one method. We know how to factor and solve quadratics, right? We're going to learn a couple more methods in this unit. But after we learn all those methods, then we will never actually solve a quadratic by graphing ever again. So why are we doing this lesson? Well, we're doing this, and it actually turns out that this is a pretty important lesson because this lesson helps us understand what the solution to a quadratic function actually means. So let's dive on into it. All right. So we're going to illustrate what the solution to a quadratic means with these three different types of solutions. So we have three different graphs here, and each one of them has a different number of real solutions. Now, we'll learn it later lessons in the future. We'll learn about other types of solutions other than just real solutions. But for now, we're going to focus on real solutions. So this graph has one real solution. This graph has two real solutions, and this graph has zero real solutions. So what are the solutions to a quadratic equation? Well, you might be tempted because these ones have solutions, this one doesn't, to say, oh, if it's flipped over, if that a is negative, then it doesn't have any solutions. Well, that's not it. That's not it at all. That's not why. Well, you may have already figured out where the solutions to these things are. The solutions to these equations are right here and right here. Okay? The solutions are also called roots. They're also called x-intercepts, right? So it's wherever the quadratic function crosses that x-axis, right? So in this case, the quadratic, this purple thing, crosses the x-axis once. It just barely goes down and kisses that x-axis, and so that is the only solution. This one crosses it twice, right? Because the vertex is below the x-axis and it's right going up, right? This one never crosses the x-axis, so it doesn't have any solution. So let's look at solving these by graphing. Now, this is going to be kind of a little bit different kind of a lesson and a different kind of a thing. If you're one of my students in class, you probably won't have a quiz over this topic. And if you do, it'll be only like the last example. But I'm going to show you a online tool that you can use to get a picture for graphs and to sanity check in the future and all that kind of stuff. So that's which is going to be the main. This and that are going to be the main points of this lesson. So first example is we're going to solve this by graphing. Okay, so in order to solve this by graphing, what we do is we change the 0 into a y and then we graph it. Now, we could go through and graph this knowing the things that we do, and we could do this by hand. We could get the vertex, use a negative b over 2a, and do all of that stuff, and that would be a good exercise. And actually, we could solve this by factoring, and which would also solve it, and then graph it using the roots that we just found. But what we're going to do instead of all that is we're going to use an online graphing calculator called Desmos. So let's go there. There is a mobile app both on Android and iOS of Desmos, and you can obviously, just like I'm doing, use the web application as well. So this is what it looks like. It is desmos.com. Desmos is spelled up here, DESMOS.com. And so we're going to open the graphing calculator, and then we're just going to plug in what we're supposed to be graphing. So we're supposed to be graphing y equals x squared minus 2x minus 8. So we're just going to, over here, put y equals x. Now to get squared, we're going to use the little caret, which is shift and 6 on the keyboard, and you see it goes up into the exponent and squared, and then we gotta push our right arrow key to get out of the exponent, just like we would on a graphing calculator, and then minus 2x minus 8. So this would be a good way if you're, later doing your homework and you're solving it by solving a quadratic equation by completing the square or by quadratic formula or by factoring, this could be a great way to check it. So we have two solutions on this equation. We have a solution right here and a solution right there at -2 and 4. So there are the solutions to this equation, right? So when we have a tool like that, that can be really handy. Now, what if it's a fraction answer? And then the solving by graphing, it gets more and more ugly. So the solutions are x equals, what did I say, -2 and 4, right? -2 and 4. So when they're nice, pretty whole numbers, and we have a tool like Desmos or a graphing calculator, it can work out okay. But rarely does life end up quite so perfect, right? So let's do another one. This guy, we're going to solve this guy by graphing it. Now, we can't just go straight to our calculator or graphing by hand. We've got to get everything on one side and 0 on another side, right? Just like as if we were factoring this, right? So we're going to start out by adding 9 to both sides. And then we end up with x squared minus 6x plus 9 equals 0. So now again, we're going to turn this 0 into a y, and we're going to graph it. So y equals x squared. Let me get this one out of here. Y equals, I should have just left the x squared. Got too excited with the backspace. Minus 6x minus 6x. Was it plus 9? Is that right? I think that's right. Plus 9. All right, so this is one example of one that just has one solution. So it goes down and just kisses the axis right there. So what is that point? So these big lines are 2s. So half of that would be halfway between 2 and 3. 2 and 4 would be 3. So it has one solution at x equals 3. Again, when the answers are nice and it's clear, this is handy, right? We won't ever be doing this on a test or something, or a quiz for me. This is more understanding what's going on. So what about this guy? Solve that guy by graphing. So we're already solved for everything on one side and 0 on this side. Going to turn that into a y and shove it in. So I'm going to delete all the way back. I'm going to leave the x squared this time, but I'm going to go in front of it and put a 2. Is that right? 2x squared minus 3x plus 5. Oh, that never crosses the x-axis. So the answer there is no real solution. Right? All right. So let's look at our last example. This is the only one that's even a little bit tricky as to what we're doing and not just purely understanding stuff, right? So we're going to look at this graph, and we're going to write a quadratic function for this graph, okay? So it has solutions at -4 and 3, right? And it's got a y-intercept at maybe about -3-ish. So that's going to come in handy whenever we get the standard form of the thing to kind of check ourselves. So let's see if we can figure out what else is going on. So if we're going to factor a solution here, and if we're going to write a factored form, let me use something kind of like a red, right? If we get a factored form, the factors are going to be x plus 4. Is a bulb flashing in your head? Maybe, maybe not. And x minus 3. Now, oops. Now, why is it plus 4 and minus 3? Well, if we were to separate this and split it out, x plus 4 equals 0 and x minus 3 equals 0. We would subtract 4 and add 3 on both sides, and so the signs will flip, right, when we go back into the factored form. The signs from the factored form to the answers, right, they flip for those roots, as I called them, or the zeros, right? So now here's the trick, though, is this, if we take this and we put a y here. This is not necessarily the right answer, either the factored version or standard form. We're going to write our answer ultimately in standard form, but because there's more than one type of parabola that could have that as an answer. We could have one that looked like more like this. This is a very crudely drawn, right? I should have, it would have been smarter actually. I didn't even think about it just this moment to make a couple more examples, like clean, pretty ones. But you can kind of have the same answers, and you can shift it up, and we widen it out. We could have something that was skinnier, or whatever. We could have a whole, like, there's tons, infinite probably, of possible quadratics that have those solutions. So we need to figure out what makes this one special. So we need to be able to pull some other information. So what we're going to do is we're going to use something that we're going to learn more about in the future, and the fact that this is probably going to be dilated in some way. There's going to be some A that multiplies, that tells how much it's stretched and whatever else. So there's going to be some sort of constant out here that gets multiplied on everything. And for all of these different types of examples on the homework, and if, like, again, if we do a quiz, it'll be only over these type of problems like this. It's going to be this type of format where you have the roots in their factored form and then some A. Now, we need to figure out what that A is. And so what we need to do is what I teach is we find a place where the graph crosses at a cross. Now, what am I talking about a cross? So what I'm talking about, like right here is a cross. You see how that crosses? This right here is a perfect -2, 3. It's not on the graph, but I'm just showing you like what I mean by a cross. So where does this would be another one at 2, 7. Where does this red graph cross at a cross? Is it at, like, we can tell, as clear as we can tell? Well, I'm seeing one right here. And this is why I don't love giving these type of problems on a quiz or a test or whatever. And if I did give this on a quiz or a test, I would, like, put some dots at some specific points. Like, I would put a dot here on the picture, and I would label this dot as 4, 2, right? I would label a point or two or whatever on there specifically if I gave this as a quiz, because if you're seeing slightly off, you're going to get a slightly different answer, and that's going to probably be close to the right answer, but not quite right. And so, again, another reason why I don't like solving by graphing, because it's just an imprecise way to do things as a human, right? And so what we're going to do, how we're going to use this information, is we're going to plug the 4 and 2 in for x and y, and then solve for a. So everywhere there is an x, we're going to put a 4. So both of these places, we're going to put a 4. Bring down everything else over here. -3 equals, and then where the y is, we're going to put the 2. So we just picked a random point from this graph, and we picked a point that looked like it was crossing at a cross, and that's all we did. And so now we're going to solve for a. So 4 plus 4 is 8. So a times 8. 4 minus 3 is 1 equals 2. 8 times 1 is 8, so this is 8a equals 2. Now we're going to, solve for a here by dividing by 8 on both sides, because that 8 is multiplied. So a equals 1/4. So now we have the equation for our solved problem here. We have the equation 1/4 times x plus 4 times x minus 3 equals y. Usually we do the y equals on the other side, and probably let's go ahead and do that here, because we like that better generally, right? So we're going to take this and move him over, erase that ugliness, and y equals all of that. Now, so this is a perfectly acceptable answer, right? But we're going to go ahead and get the standard form of this by distributing this out. And we're going to do that because that's going to let us kind of confirm this -3 as the C, or at least near that, right? it's going to let us kind of sanity check our answer. So let's do this distributive property right here. X times negative 3, 4 times x, 4 times negative 3. Then we'll take care of the 1/4 after that. So y equals x times, don't forget to bring down the 1/4. X times x is x squared. X times negative 3 is negative 3x. 4 times x is plus 4x. 4 times negative 3 is negative 12. Negative 3x plus 4x. We've got common like terms. That's the word I'm trying to say, right? So negative 3x plus 4x is just x. So this is y equals 1/4 times x squared plus x minus 12. So now we're going to distribute this here. And then I'll write our answer over here. I'll even write it big so it's easier to tell what's happening. So our answer is y equals 1/4 times x squared plus 1/4 x minus 12 times 1/4 is negative 3. So it does, in fact, cross right there. So it's got that going for it. That is it, ladies and gentlemen. That's a shorter lesson than the other one. Hopefully that'll make up for the long lesson on lesson 1. We will see you in the next one. Have a great, grand, glorious day. All of those things. Bye-bye. See you later.